Hello friends and welcome to our second session on three hinged arches. Today we shall start with the numericals. Start with very simple numerical like this. Here we have been given a three hinged arch. Okay, very simple. Span of the arch is 20 meters. There is one point load 20 kilonewton acting at 6 meters from support A. What we have to find is support reactions which are at A and B. Then we have to draw BMD for this arch and we have to indicate position of maximum bending moment in this arch. Okay, so let us start with, we have to find support reactions. So we have this vertical reaction, we shall say VA. Another vertical reaction is VB. Then horizontal reactions are there, HA and HB. Okay. So four reactions are there. We have three equations of equilibrium. Now, when we are solving or analyzing any arch, what is our first step? Consider the given arch as simply supported beam. Okay, so draw a simply supported beam, show the external loading as it is. This is 6 meters, so this remaining is 14. And now using three equations of equilibrium, we will first of all find VA and VB. Okay, so summation of Fy is equal to 0. So this is going to give us VA plus VB is equal to 20. Then summation of moment about end A, we can use any end. So minus VB into 20 plus 20 into 6 is equal to 0. Okay, so what is VB? 20 into 6 upon 20, so 6 kilonewton, correct, which is upward. And VA, substitute this value of VB here, we will get 20 minus 6 is 14. Straightforward and simple. Vertical reactions are over, VA and VB. Now we have to use the remaining condition of equilibrium for finding out HA or HB. HA is equal to HB. Why? Summation Fx is equal to 0. It is going to give us HA is equal to HB. Okay. Now these two unknowns we have to find. So for that, as discussed yesterday, we need additional equation of equilibrium, that is bending moment at the crown is 0. So we will separate out the arch from C. Either we will consider A to C or B to C. Considering arch from B to C part is easy because there is no external loading on C, correct, or anywhere between B and C, not only C. So this is VB, which we have calculated as 6. And here is HB. So how much is this distance, horizontal and vertical? Show them here. It is 14, correct? And central rise is 5 meters. Isn't it? Central rise YC is 5 meters. So for this free body diagram of the arch, now we will apply equation of equilibrium of moment, correct? Summation of moment about C. That is what our condition is as per yesterday's discussion. So HB into 5 and 6 into 14 will be anti-clockwise, so negative. So minus 6 into 14. So how much is HB? 84 upon 5, correct? So let us calculate. So 84 upon 5 is how much? 16.8. Correct? So there is one mistake. This distance is not 14, this is 10. Okay. This is 10 up to this. Okay. So this 14 is not there, it is 10. So 10 into 6, 60. 60 upon 5 is 12. It is not 16.8. Okay. So HB is 12. So VA 14, VB 6, HA or HB 12. Fine. So support reactions are over. First part is over. Now we have to draw BMD for this. Now I will rub this. So now let us draw bending moment diagram for the frame, for the arch. This will be bending moment diagram for H into Y, because if you remember yesterday's equation of Y, what was Y equation? 4YC upon L square X times L minus X. So here power of L is 2, correct? And Y will vary as per L. So H into Y will be parabolic. As far as beam moment is considered, so one thing you need to understand first, whenever you have to find bending moment in arch, okay, it is always given by this equation. It is beam moment minus H into Y. Always remember this equation. Beam moment minus H into Y. What is beam moment? Whatever the arch and loading is given, you consider that as simply supported beam. Show the external loading, draw these or calculate the vertical reactions like we have calculated here, and find out beam moment at each point. Let us say this is point D. Okay, so at point D, what is bending moment or beam moment? VA into 6. How much is VA? 14. 14 into 6, so 84, correct? So at this point approx, beam moment is 84 kilonewton meter. I'll write directly because it is simple. Then next prominent point is C, which is hinge, correct? This is point D, this is A, this is B. So at D, beam moment is 84, correct? On C, it is going to be 0. Then it will continue up to point B, and this will remain 0. This 84 is from this reference line, okay, because 0 is here, so 84. Now net movement on point D is, you have to find out using this equation, bending moment in arch. So I'll write now this here as bending moment at D is equal to beam moment 84, which is 14 into 6, minus H into Y. How much is H? 12 into Y, D. Okay. So we need Y ordinate here. How to calculate that? Use this equation. X, we know how much is x? It is 6 meter. So you substitute x as 6, you will get yd. So yd is equal to 4 times yc, central rise, it is 5 upon 20 square, which is span, into x is 6 into 20 minus 6. Okay. So I'll rub this and calculate what is yd. So 4 into 5, 20 into 6, 20 into 6 into 20 minus 6 is 14 upon 20 square. Okay. So this is 4.2. So yd is 4.2 meter. Substitute here. So 84 minus 12 into 4.2. Calculate. 84 minus 12 times 4.2. So it is 33.6 kilonewton meter. Net moment. Net moment. It means from here up to here. Correct? So net moment is 33.6. And how much is this? 12 into 4.2. So if you add 33.6 and 12.4.2, you will get 84. Okay. So this is net moment. Now from A to C, we have got maximum moment. We have to indicate position of maximum bending moment. So since there is some external loading on A to C part, there will be maximum positive bending moment, 33.6. So this is positive value. Okay. But as you cross point C up to B, there is always negative value. But we do not know how much is that negative value, correct? So we will find that value also, because it is not specifically asked if we have to find positive or negative value. So we will find both. So we will find now maximum negative bending moment. What is maximum positive value? 33.6. Okay. Now we have to find maximum negative bending moment. Correct? So now I shall rub this. I will rub this value also. 33.6 we have here. Now I will draw C to B part. Okay. So this is B. Here is C. So somewhere here from B we will have maximum bending moment, correct? So what we will do is we shall consider one section at a distance x from B, and we will write down equation for bending moment at a section x from support B. Now we have considered this section, we have to consider moments on right hand side of the section. Please make it clear. One assumption about sign conventions. My thumb rule: if this is the situation, this is the section, dotted line, vertical dotted line is the section. If on left hand side of the section moment is clockwise, or at the same time on the right hand side if it is anti-clockwise, in this situation I treat such movements as positive. Okay. Another exactly opposite. Now this has to be anti-clockwise, this is clockwise, then this will be negative. So moment on left hand side anti-clockwise or moment on right hand side of the section clockwise, moment will be considered negative. What about shear forces? Upward on left hand side, correct, or downward on right hand side, positive shear force, and downward on left hand side or upward on right hand side, negative. So these first two are for bending moment. Third and fourth, they are for shear force. Okay, so this is the sign convention I am going to use throughout. Okay, now I will rub this. So following these sign conventions, now we will write equation for bending moment at x. So our section, we are considering right hand side of the section. So VB, how much is VB? I think this was 6, so this was 14, so this is 6, okay, and this is 12. So bending moment at x is 6 into x. So this is anti-clockwise on right hand side, so positive, minus HB into y. So h is 12 into y. We do not know how much is this y ordinate. Now we have to find again using yesterday's derivation. So y is equal to 4yc upon L square x into L minus x. So how much is 4 times yc? Yc is 5 upon 20 square into x into L is 20 minus x. So 4 into 5, 20. 20 upon 20 square is 1 upon 20 times. Now we will multiply x to the bracket. So 20x, correct, minus x square. Now simplify again. 20x upon 20 is 1x minus x square upon 20. So how much is 1 upon 20? 1 upon 20 is 0.05. Okay, 1 upon 20, 0.05. So 0.05 x square. So this is value of y, equation for y. Okay. Now please remember we have to find maximum negative bending moment. That is why we are doing this. So we will now substitute equation of y here. So bending moment at x is equal to 6x minus 12 times this bracket, x minus 0.05 x square. Simplify this. 6x minus 12x minus plus, correct, 12 into 0.05, how much? So it is 0.6 x square. So 6x minus 12x is minus 6x plus 0.6 x square. This is bending moment at x. So we have to find x value such that we will get maximum bending moment at x. So differentiate this d by dx of m, we shall say, or bending moment at x. Okay. Is equal to 0. So differentiate. Minus 6x, derivative is minus 6 plus 2 into 0.6 is 1.2, correct? 2 into 1.6 is 1.2, x is equal to 0. Simplify this. So it is 6 upon 1.2. So it is 5. X is equal to 5 meter, but we are measuring x from support B. So we will substitute this value of x in the equation of bending moment, let us calculate. X is equal to 5 meter. Okay, it is equal to 6 into 5, 30, minus, or rather we have to substitute here. Instead of this equation, we have to substitute this value here. It will be somewhat different. We will get now maximum negative bending moment. So minus 6 into 5 is minus 30 and plus 0.6 into 5 square. Calculate. Minus 30 plus 0.6 into 5 square. How much? Minus 15. Answer is minus 15 kilonewton meter. So this is maximum negative bending moment. It is here at x is equal to 5 from B. Okay, and that value is from where to where? Here. Not yes, it is here. This value is minus 15. Okay, so that ends our problem. Thank you.